Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics.
Ladies and gentlemen, welcome to the match between the geometry of the Carolina Bays and the dates of the Carolina Bays. The rules of mathematics and science will determine the winner. The Carolina Bays are shallow elliptical depressions with raised rims whose major axis is oriented toward the Great Lakes. Interpretation of the geometry and of the dates lead to different conclusions about how the bays were created. The elliptical geometry corresponds to cones inclined at about 35 degrees, which implies that the bays originated as inclined conical cavities produced by contemporaneous impacts on liquefied ground. The dates tell a different story. The terrain where the bays are found has been dated from 12,000 years ago to more than 140,000 years ago. The wide range of dates indicates that the Carolina Bays could not have formed all at the same time by a single event, and it implies that the bays formed by gradualistic processes over thousands of years, most likely by the action of wind and water. This video discusses the evidence for the geometry and for the dates. Radiocarbon dating was developed in the late 1940s for determining the age of an object by using the properties of carbon-14, which is a radioactive isotope of carbon. The method is based on the fact that carbon-14 is constantly being created by the interaction of cosmic rays with nitrogen in the atmosphere. The resulting carbon-14 combines with atmospheric oxygen to form radioactive carbon dioxide, which is incorporated into plants by photosynthesis. Animals then acquire carbon-14 by eating the plants. When the animal or plant dies, it stops exchanging carbon with its environment, and from that point forward, the amount of carbon-14 begins to decrease as the radiocarbon decays back to nitrogen. The half-life of carbon-14, which is the period of time after which half of a given sample decays, is about 5,730 years. So, measuring the amount of carbon-14 in a sample from a fragment of bone or a piece of wood can be used to calculate when the animal or plant died. The older a sample is, the less carbon-14 there is to be detected. Radiocarbon dating can only be used for dating organic materials. Radiocarbon dating can provide date ranges of up to 50,000 years. Radiocarbon dates are always given relative to 1950, which is considered the present. So a radiocarbon date of 458 before the present means the year 1492 AD, which is the year when Columbus sailed to America. The convention to use 1950 as a reference date makes it possible to compare radiocarbon dates published in journals without having to adjust for the date of publication of the journal. There is another kind of dating called optically stimulated luminescence, OSL, that was developed in the 1980s. It can determine ages from 100 years to 350,000 years before the present. OSL is only used to date minerals and sedimentary layers. Radioactive isotopes of uranium, thorium, rubidium, and potassium that occurred naturally in the soil produce ionizing radiation that causes electrons to become trapped in defects of buried quartz crystals. The number of trapped electrons increases in proportion to the time that the crystals remain buried. High-energy cosmic rays that penetrate the Earth also contribute to the buildup of trapped electrons. Exposure to sunlight or intense heat releases the trapped electrons and resets the sample. Luminescence dating estimates the time since grains of quartz were last exposed to daylight by detecting their subsequent response to light of specific wavelengths. The procedure for collecting samples for OSL testing has to avoid exposing the sample to light. The stratigraphic context of the sample is important because the depth of burial below the landform surface is needed to calculate cosmic dose rate. It is also necessary to record latitude, longitude, and elevation of the sample to calculate the cosmic dose rate, and the sample depth must be more than 1 meter below the landform top to minimize cosmogenic dose errors. As already mentioned, OSL is applicable to gradualistic sedimentary processes, and the problem with using OSL on the Carolina Bays is that the bays were produced by oblique impacts and not by sedimentary processes. The inclined conical cavities produced by the impacts were transformed into shallow elliptical bays by viscous relaxation without exposing the subsurface to light. Thus, the OSL dates of the subsurface of the bays corresponds to the age of the terrain and not the date of bay formation. From the time that the bays were discovered, many geologists suggested that the Carolina bays were formed by wind and water processes because the bays did not have shock metamorphism, meteorite fragments, or other evidence of extraterrestrial impacts. Tests of the bays by Brooks and his colleagues using optically stimulated luminescence produced a wide range of dates. The dates for Big Bay in South Carolina showed that the shorelines became progressively younger toward the bay interior, and that the wind-blown sand sheet originating from the watery river on the west was moving over the bay 74,000 years ago and was later modified 33 to 29,000 years ago. Brooks and his colleagues proposed that the shape and orientation of the Carolina bays developed through stronger than present southwesterly winds blowing over water-ponded and shallow depressions. The depressions were expanded and oriented by wave erosion, resulting in bay elongation perpendicular to wind direction and the formation of peripheral downwind sand rims and shorelines on the eastern and southeastern margins. The authors also stated that the age ranges for the Carolina bays also correspond to the ages of other aeolian landforms in the coastal plain, including sand sheets and dune fields. James Kennett and 25 co-authors examined dates associated with the Younger Dryas cooling event. Kennett says that radiocarbon 14C measurements are typically very precise, with uncertainties of plus or minus 20 years to plus or minus 30 years at 11,000 carbon-14 years before the present, but high precision does not mean high accuracy. Numerous problems can produce erroneous ages and age reversals in stratigraphic sections. For example, carbon-14 concentrations have varied unevenly over time for many reasons, including from carbon turnover in the deep oceans and the release of carbon-14 from biomass burning. In addition, there can be considerable uncertainty about the association of charcoal ages with paleontological and archaeological assemblages caused by the vertical transport of charcoal in sedimentary sequences through many processes, including plant bioturbation, especially roots, animal bioturbation, and redeposition by wind, water, and ice. In 2009, Richard Firestone reported that the carbonous spherules from the Carolina bays and from the Gainey-Clovis site were radiocarbon dated at the Keck Carbon Cycle AMS facility at the University of California in Irvine. The dates summarized in this table vary from 275 years before the present to 755 years in the future. These dates are inconsistent with the age inferred by the stratigraphy of the samples and strongly suggest that the carbon spherules are enriched by a factor of about 5 in carbon-14. Results like this are very frustrating for the researchers because they may reflect improper methodology or sample contamination. Carolina bays in level terrain with a deep layer of unconsolidated soil are perfect ellipses. An ellipse with the same width-to-length ratio as a Carolina bay will fit the bay exactly after scaling and rotating the ellipse. Although many bays have been deformed by terrestrial processes and human activity, the bays that are well preserved have an elliptical shape. It is possible to conclude that the archetype shape of the Carolina bays is elliptical and that the bays can be modeled as mathematical conic sections. Nebraska also has geological structures with the same elliptical geometry as the Carolina bays. The Nebraska rainwater basins are oriented from the northeast to the southwest, almost perpendicular to the orientation of the Carolina bays. The Nebraska rainwater basins occur on terrain that is 550 to 650 meters above sea level, mainly on sandy soil south of the Platte River. Nebraska has not been close to any sea since the Laramide orogeny started building the Rocky Mountains and drained the western interior seaway more than 60 million years ago. The Nebraska basins exist on a loess-covered topography dated at approximately 27,000 radiocarbon years before the present. In 2010, Davies and Gilbride calculated that the major axes of the Carolina bays and Nebraska rainwater basins converge in Saginaw Bay. The glacier ice impact hypothesis proposes that a meteorite impact at this location during the Ice Age ejected pieces of ice in ballistic trajectories. The impacts of the ice boulders liquefied the ground and created inclined conical cavities that were transformed by viscous relaxation into shallow elliptical structures in Nebraska and the East Coast. In 1977, Raymond Kochorovsky conducted a sand table experiment where he created a circular pool and used a fan to simulate the winds that he proposed shaped the Carolina bays and their rims. He reversed the wind direction at 15-minute intervals during the experiment. The wind modified the shape of the original pool, but it did not produce an elliptical shape. By contrast, impact experiments produced elliptical structures. Oblique impacts with pieces of ice on a viscous medium produced inclined conical cavities that are elliptical when viewed from above. The impacts produced overturned flaps analogous to the raised rims of the Carolina bays. In 2012, Ted Bunch and 17 co-authors were looking for evidence of a cosmic airburst or impact 12,900 years ago. In the rim of a Carolina bay near Blacksfield, South Carolina, they took samples for optically stimulated luminescence at 107, 152, and 183 centimeters below the surface. The layer at 107 centimeters had an age of 11.5 thousand years. The layer at 152 centimeters had a date of 18.5 thousand years, and the layer at 183 centimeters had a date of 12.9 thousand years. When the paper was written, the prevailing theory was that the Carolina bays had formed by gradualistic sedimentary processes, so the sample at 152 centimeters was excluded because of the large magnitude of the age reversal. However, that kind of reversal is exactly what would be expected in the inverted flap of an impact, as shown in the inset image from the book by Professor J. Meloche. You have seen the evidence. Did the geometry convince you that the Carolina bays were created by impacts? Or did the diverse dates convince you that the bays could not have been created by impacts? This is the dilemma that scientists face today. The dates deny the possibility that the bays were created contemporaneously, but they do not offer an explanation for the regular shape of the bays. The geometry proposes a mechanism of formation for the bays as inclined conical cavities and claims that the diverse dates are features of the terrain that are unrelated to the time of emplacement of the bays. Pow! The impact knocked the wind out of the Aeolian hypothesis! Ladies and gentlemen, this match is over! Stay tuned for the championship match!
Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.